All right, I'm talking about fuzzing Samba. It's kind of a tutorial, and so it goes for 90 minutes, and I guess there'll be a little break in the middle while people switch rooms or whatever you do in this thing, if you don't want to watch the whole lot. Now, if people want to interrupt and ask questions, that's a good thing, probably, because 90 minutes is a lot of talking for me. So if you want to follow along, you'll need a Samba source tree and a program called Fuzz, which I wrote an email to the list explaining what you need to do. If you saw that, that's good. If you didn't, well, you need to clone these things and build Fuzz. So I'll just, this is what you need to do. You can just watch this while I talk. Now, Fuzz is a framework for which uses libfuzzer. Maybe I'll just go back to the slides actually. So you need Fuzz, you need Samba, and you need the Samba fuzz seeds directory. But the fact that Samba fuzz seeds you can just ignore for the moment because I'll get to it later. Now, so is anybody actually? I'll just see if I can look at your look at the chat because I can't see the chat. You don't get to practice being a speaker until suddenly you're a speaker, and suddenly you get these tiny little Zoom windows. You can't really work out what to do. Okay, what have I done? Okay. Is anybody wanting to follow along and actually do the compilation and do the things right now? You'll have to speak up because I don't know where the chat's gone. Because if you aren't, if no one's actually doing it, I'll probably alter my talk.
Well, I'm going to follow along, Douglas.
Oh, cool.
But if I get behind, it's fine. So you go at whatever pace you feel comfortable with.
Yeah. So, David, have you already installed those things?
I just installed Fuzz.
Fuzz, right? Okay, good. That's perfect. Okay, and it worked probably. So if you do need to install Samba, which David obviously isn't going to need to do, this is like a little 2-minute lightning talk about how great Bootstrap is. It used to be in the old days, if you needed to install Samba and compile it from scratch, you used to have to look on the wiki and try and work out all the things you needed to install, the prerequisites. But now we have a little script that does it for you. So once you have the source tree, you just run this Bootstrap script and you get everything you need, and that's fallen out of the CI builds because this is what the CI does. Now, when you're compiling Samba, you don't do what you normally do, which if you're a developer, you might go configure.developer, or you have some other thing. So if you've got a bin directory, you just get rid of it because anything that is configured in a normal way for this directory, you don't want it. So if you're starting with a fresh one, then that's good. Now, so you need a special configure line, which you can see there. I should have actually posted this on the wiki or something like that. So enable libfuzzer turns on the fuzzing and turns off a lot of normal things that get compiled, so you don't get the normal binaries and stuff. Address sanitizer is something useful for the fuzzing. It just catches every memory error, and not just if you happen to walk onto another page and segfault. And then you tell it to use the Hongfuzz Clang wrapper, which is like a compiler that I think it basically just puts all the options on at once, which are, using sanitizers and instrumenting the build as much as it can. And then you turn off warnings, or the warnings as errors, because Clang has different warnings than GCC, and you'll end up with things just going wrong. I mean, your Clang will warn about something that GCC wouldn't, and no one tested that until you just did now, and so you just end up chasing things you don't care about. And the same with the ABA check disable and without get text, they'll just cause you problems. Here's a slide that says all that, but I left that one up so you could copy it. So then you do the build, and then the Samba fuzz seeds, as I said, just forget about that for now. So in that replay of the prerequisites, so I'll skip to the. So I'm doing these replays just because it kind of gives me a sense of timing of whether how long I should take. That's my theory anyway. So the build is actually a little bit quicker than usual, I think, because you build less. You don't use the compile can be quite slow. I mean, the configure can be quite slow. Now, here we go. So while that's going, I'll just talk about what fuzzing means. So David, this is your chance to catch up. So it means testing a program with random input. I think it's derived from, the fuzz on a TV screen. It was first done, or became, the term derives, I think, from the 80s or 90s. I can't remember now. And there was basically people wrote papers where they sent random strings and options at like standard Unix commands, and many of them crashed. And they repeated it every few years after that, and still many of them crashed. And now that was around the time of the internet worm, and so it was suddenly these kind of security problems were noticed, like for the first time that there were issues. But this kind of fuzzing from the outside of sending random strings to programs is it doesn't work very well because it doesn't know what kind of programs. It's trial and error, whereas what we're going to talk about today is coverage-based fuzzing. So you can't just pipe noise at Samba because there's too many interfaces, and there's packets of size at least, over the wire, which you need to at least chunk up your randomness. And but there's just so many things that are Samba that you can't really just say we're going to hit it like this. And there are so many random strings won't mean anything. So while black box fuzzing is a thing that people do, it's not something that I'm going to talk about much, because we have a much better thing that we're doing with Hong Fuzz, which is coverage-based testing, where you compile your binary so that the fuzzer can look into it and see which branches are being taken, and then it can just try and make sure it's following all the branches. So when an input finds a new way to go, a new path through the program, or even just a tiny little bit of a new path, that input is kind of, it joins the breeding population and becomes a seed for other ones that are trying to do the same thing, or find new territory in the same kind of area. So it'll find the corners of your program much faster, at the expense of making your program a bit slower by putting video cameras on every corner. So it does this by making a control flow graph where, for this little example, this little bit of C code, which is sort of nicked from Samba. There's an if branch, a little block with an if. Now, it's not every instruction or every line. It's kind of like every time you can either converge or diverge in the way you go. So and the nodes are the before the if, after the if, and the block itself. And you basically work out where the edges are, and you just count which ones you've gone on, I think. And I haven't really looked into it, but apparently they actually, in that case, you'd have an implicit else because it makes the problem more practical. So now here's the next. Right, okay. So I'll just see where we're at there. Okay. Now we can't just take the whole of Samba, even if Samba was one binary. It is too big, and it would just I mean, it's got too many holes in it for a start, but it's just too big, and you wouldn't get good coverage of the whole thing because it would just take way too long to get all the way through. But you can actually, if you think about what your problems are, usually it's something like you're getting data from outside and you're putting it into a struct, and then you're using that struct. And if you make little programs that do that kind of thing, using your Samba code, then you can fuzz specific parts, and you can give those things a really good workout. and there'll be a whole lot of internal code, which is just passing around things that we already trust, that we don't really need to fuzz so much, because by the time anything's got to them, it should have crashed already. And so, yeah, we want a manageable size. We want things that bring data across trust boundaries, which basically the outside world coming into Samba is the boundary that matters. I don't know if we actually would do any fuzzing apart from that kind of thing. And then they need to work with a blob of a string of bytes of uint8s. Well, so data blob is the Samba word for basically a pointer to some bytes in a length, and that's what these a fuzzer will take. So this is the API that the libfuzzer uses. Libfuzzer is the fuzzer that's behind HongFuzz. Now the orange one at the bottom, the Initialize, it's optional, except in Samba it's not optional, but usually in Samba it does nothing. So usually that what you see there is all it does. And the top one, the test one input, so it always returns 0. These both always return 0, or the top one can crash. Initialize shouldn't crash. And that's the you don't report errors by returning 1 or anything. That would I don't know what it would do. You just return 0, or you abort, or whatever other way you can crash. And the crash then gets that's a finding, and that gets reported on. Because from the point of view of a fuzzer, if you give it something invalid and it says, you know, that's the bad string that doesn't look like a DN or whatever it's meant to look like, you're not surprised. You want it to be saying that's invalid. You know, you want the internal things to be returning error codes all over the place, and then you just say, right, that's good. Okay. So here's a program. This function has a bug in it. It will crash if you give it a certain string, and this is where the crash happens. And if you give it 5 bytes that match that, it'll crash. So now, if you had a blackbox fuzzer, that's 40 bits. So you'd be, you know, that's what is it? 1 trillion combinations. And it would take a long time because, well, yes, assuming it knows how to use 5 bytes, because it would have to be, it would start up the process for each one saying, you know, let's try another string. Whereas with libfuzzer, in the coverage-based fuzzer, it draws the graph, and it says let's find out all these edges. And so it's, and the first part of the puzzle is that it says, oh well, I keep whatever I give it, I keep returning 0. You know, I keep going in this branch until it finds something with length of 5. So we don't know how long it'll take to do that, but we're calling it epsilon. And then it'll unroll this because it's comparing with the constant string, and it'll say, well, you know, it's looking at 1 byte at a time. We'll say, well, is it an S, is it an A, and what is it? 1280 combinations at the worst, it'll come through and it'll crash with a board. So it'll find this instantly, whereas the other one would, it's like a black box password guesser. Okay, I'm getting messages from Zoom saying people can see my screen. I was hoping so. And there's no process startup. So yeah, that's an instant thing. So now normally you don't have that in there. You have something that you call a Samba function. And the bits of code that you know which you talk to the outside world, then you know what functions you're looking at. But if you don't, you can just grep for things that sound like they're getting something. And you can grep for strings like parse and pull and get and look for things that take a U and take T and a length. And if you find something like that, and you don't even need to know much about what it does, you can just chuck it in a fuzzer. So there's that in a slide. It often these kind of functions will they'll take in that thing and you give it a pointer to something to fill out, or it'll return a pointer or something, and then when you look at it, you just kind of look at it, and if it's more than you think you can understand in a look, then it's fuzzable. That's kind of my theory. And if it works with the outside world, which is generally the case. I mean, if something's taking a urinate and a length, then Samba doesn't know much about what it's dealing with. It's come from somewhere that we're not understanding, unless it's decoding a key or something like that. And there are things that aren't actually used, like there's this one I thought would be a good example. I decided against it for a couple of reasons. One is it's only used in tests, but this function, it branches out into a whole lot of other pool functions. Message pool, which sounds like, it's pulling messages, sounds like something that would be a trouble if it was broken. So I didn't want to fuzz it because it's only used from tests, and I didn't want to fuzz it in this example because if it turned out to have a problem, then that would be bad. So, and then this other one, base 64 encode and base 64 decode, we've got a few functions that do that. They look kind of messy, and they look like they're a little bit hard to understand, but they've been used so much, and they're not very big, so they probably aren't going to find something. But it's worth looking into. So I chose this one, which is a part of the printing thing. So this, it doesn't take a uint8t, it takes a character line or char star, which you can convert your thing into, and it will produce a buff struct and a status struct, and you also need to give it a printing type and a first Boolean. And one of the nice things about it is it's getting output from another process on the system, and it's probably running it as root and stuff like that. So even if I find a problem and it's in the talk, it's not really it's a little bug to be fixed. It's not that there's a I won't have to swear you to secrecy and all that kind of stuff. I don't know who's even listening, right? And I might fix a printing bug, and I might get my t-shirt and all that stuff. So I'll just look through the function. We should take you through the function. So the first thing it does is it switches on printing type, and just calls another sub function for each different type. And then there's this bit where if we're a developer, there's the next case, and we're not developer here because on those configure flags I didn't put developer in. And then it goes and does some more things, and it's doing these structure kind of functions. Any function that starts with str is going to be trouble for somebody. So that always makes it fuzzable. And it just does a lot. Like that looks like to me enough work, without looking any further. It's calling other functions. It's doing string handling. It's going to probably have something that the fuzzer will find. So what you do is you start a file with your template, your two little your initialize and your test one input, and then we put the function we're wanting to fuzz in there, and this might compile because we've turned off warnings as errors, but we shouldn't compile it like this. We're just declaring these things, not initializing them very much, and then calling the function. And we're not using our input, so it's not worth it doing anything. Now, because we want to char star with a null terminated string, at least I assume that's what we want. That's what you think they want. It's called line, so it probably means they don't even expect a /n in there. You'd think you could do this, but Hongfuzz doesn't really like you to muck with the input. So what I'm doing there is because the input is a random string, you don't know what's in it. It might have a 0 byte somewhere along, in which case to the called function it would look like the line ended there, but it might have none in it, in which case it would walk off the end of this line of the buffer, and it would crash because it's your fuzzer's fault. So you'd think you could just put a null byte at the end, and that would be fine. But no, it doesn't like that. You have to copy it. So I tend to do this. So the way Hongfuzz runs these things, it's not using threads, so you can use a global. You could do it on the stack too. Make a big buffer, and if it's bigger than that big buffer, which it actually won't be because we check it in other places, and the way we call Hongfuzz, it's only getting to be 10,000 or something long. then you just say, no, this string's okay. And so if Hong fuzz starts sending your fuzz function a whole lot of long strings, they'll all from the fuzzer's point of view, from Hong fuzzer's point of view, there'll be failures because they'll be returning 0, going the same branch every time. And in fact, I don't like this, and it'll hit on some shorter ones that go down past it. So if you're going to tell Hong fuzz to go away, I can't cope with this line, do it early, like the top of your function, and it'll get pissed off with going that way, and it'll go down the other way. Right, so then we copy the line into our buffer and put a 0 at the end. And then, so the kind of thing, we've got this printing type here, which we know from looking at the function that there's going to be 14 or 13 of them, or at the most it's 14, but it's less than that if you don't have developer on, I think. Or maybe I can't remember. But anyway, so if you take your first byte, this is what I do. So now you say you need 1 byte. And if you've got less than 1 byte, meaning no bytes, then you just bail. And there aren't many strings that have no bytes, but we'll try that one. So you take your first byte off the string and just going to move it all along, and take your 4 bits to be the printing type. And I've checked in the function that if it's out of range, it just goes default. It goes to the BSD printing thing. So we could have the whole 256, but that would be boring. And yeah. So we've done that one, and then the first flag, because we've got this in our byte that we've pulled off the front, we've got extra bits that we can use one of them to be the first. So what I'm doing there is, pulling bits of the UN8 input to B flags and stuff, and it's kind of quite efficient packing of that, because you don't want it to be wasting time randomizing those other bits that you're just throwing away, really. Although I probably wouldn't waste much time. I just like to be efficient with these things. And so then the whole thing, the whole fuzzer looks like this, apart from our headers and copyright, all that stuff. Is just everything we've just talked about. So it's going to, it finds the printing type, the line, and these ones get filled out. And we don't care what's in them. Now, if we could extend the, we probably should extend the fuzzer actually, so that if the status was good, then we assume that that's good, and we do whatever thing you do with those things. So that's making sure that not only does the fuzzer fuzz correctly, or run this function correctly, it the struct that it's made is good, because that's the whole point, really. And then using trial and error, I found some headers that made it compile. You always want the fuzzing.h. And I assume those ones are all the right ones, but it works. And then, so in the W script build, you put in this little thing. Now, there's a few so the dependencies you add this fuzzing and AFL fuzz main. At this stage, let's just say it's boilerplate. If fuzzer equals true means that it'll be built in fuzzing mode and not normally, and things that don't have fuzzer equals true, which is like every other normal program, don't get built. So when you look at yeah, that's why I didn't do it live. You've got some Python stuff, and you've got all your fuzzers, and you don't get any. You don't get LDB search, all that stuff, and you try to minimize the dependencies more than usual. I mean, you normally want to, but here you'd want to extra so because it slows it down to have all those extra edges in there of your control flow graph. That is, every time it runs, it's looking to see if you've gone through 300,000 edges, when in fact you know that your little program can only maybe reach 1,000 or something, which or you don't know what it can reach, but it's something like that. In this case, this is like the opposite of minimal dependencies, and I don't know how to get around that because I was just trying to make it compile. So then the extra building it is pretty simple, and then running it, I got this, which I'm not used to seeing, but the address sanitizer complained that this secrets thing was included twice from that one and that one. I'll just actually see if I can shrink this. Oh no, it's not gonna. My browser doesn't want to shrink this, the size of the text anyway. So I imagine this normally happens and nothing complains. Now, normally when I write a fuzzer, I don't use SMB base, and this has happened to Michael Hanselman, I think his name was, who was fuzzing a while ago. So that was interesting, but it tells you how to get around it. If you find that, you just need to do that. And yeah, so like this. So now if you run it, just run it, it doesn't complain, it's wanting input from standard in, so I killed that. And then if you give it a file, it took a couple of seconds to process that one. I put the time in there, but I didn't actually put it in the printout. So like that's, you can use that as a standalone executable, or you can use it as a lib fuzzer fuzz target using Hong fuzz. Yeah, using Hong fuzz is a little bit tricky it's got heaps of options. And it makes files all over the place. It makes every time it notices something, it writes a file. I mean, it does, the log, and it names it by the process ID. If it finds a crash, it writes a file. When it finds a crash, it writes to another log. If it finds an interesting thing that goes in a new direction, it writes a new seed file. And these kind of just, if you leave it to default, they're just going to end up spreading around your entire life. So what I've done is I've wrapped it in these little scripts, mainly this run script, so this is mainly to David, who's following along. I make this directory called fuzz, and I copy this thing from the Samba fuzz seeds repository, which was mentioned in the email, into that there, and then I copy actually I don't do this, but this is how the one on the repository works. You copy the Hong Fuzz binary that you've made into that Samba, that fuzz subdirectory, and you can copy the seeds, and that will add to the public seeds repository if you push it. But you can do that later. Like you can copy it across. You just don't publish things too quickly. So Fuzz Run is the thing that does it all. And all it really does is it does this stuff to kind of it gets the name of the fuzzy that you're trying to run, and it puts all the things into tidy little directories, and that fuzz directory inside your Samba folder, which isn't in the Git tree, and I put a git ignore in there so that then Git tools don't start saying you've got a million uncommitted files. And so it runs this bit down here, which is these are what these are. So the -v means when it finds a crash, it'll try it again straight away. And if it's flaky, well, if it doesn't crash straight away, it'll say it'll decide it's flaky. It'll still report it. It can still be flaky and work twice, of course. And the other ones decide where they save things. Now the -t, now if you always have a timeout. You can choose without the capital T, capital T, to have the timeout just be, oh well, we didn't get a result. But what I prefer is to make the timeout send a nasty signal from Hong Fuzz's point of view, rather than just a kill, because you want to know if something's in an eternal loop. You want to be told about it, or that you're just taking forever. And often things do take, well, more than 20 seconds is not uncommon for some fuzzers just running tiny little programs. And then this -f max size, and that max size is just set in this file here somewhere. And so if I want a different max size, usually I start small and grow bigger. I just edit the file like this. It's all configuration for editing bash scripts. And I've grown with this kind of, you can't really call it infrastructure. It's kind of, these scripts have just kind of evolved from my usage. And I would like to make them better. Well, not better. We'll kind of settle on a proper something that could go in the Samba tree, but I haven't got around to that. And I think it's good to have some time of them kind of being out of the tree and edited by hand, so that you can work out what's useful and what's not. But so anyway, they're in the other repository where they're completely unstable, except that I never bother pushing to them. So the ones there are unstable, are stable, but usually out of date. And it writes a report to that file, which is a strange name, but it's kind of based on what the default was. And it's got a C directory, and then anything else you pass Fuzz Run the name of the thing you want to run, and then anything else gets passed on to Hong Fuzz. So you could, like a dash capital M will make it minimize the corpus, for example. It's the only usage. Now that's I'll just run that thing. Sorry. Oh, here I'm going through all that stuff. I thought I'd try terminal recording, but it just made my fingers look so slow. I don't really like it. And I keep doing the wrong things. So I'll fast forward a little bit. Part of the problem is it's the middle of the night, and I was doing these slides in the middle of last night. So where am I? Right, here it goes. This is the interesting part. You get to see it going. Oh no. Oh yeah, so I needed to add the patch that we've just written on the screen, and then make there must have been some other update, because it shouldn't be doing more than that. Oh well. And so what's going to happen is you'll see me running the fuzzer. Here it goes, and you see the results at the top of the screen. Now this is how many iterations it's gone through. So this gets doing 6,000 a second, which is medium speed. It hasn't found any crashes yet. It's found 500 edges out of 300,000 in SMBD. And each time it finds a new edge, see, this goes back to 0, and it kind of writes the size of the new file that it found that's saved as a seed. So it goes in the corpus, and it, okay, the big corpus is bigger than the edges. It finds something that it likes. Now the coverage, if you're running on a bare metal machine, you actually see more things here because it's got perf counters and stuff like that. But when this is the cloud machine, and the host eats up some of the perf counters and that kind of stuff. So the bare metal, it has more ways, and there it's gone and found, it's going to crashed again, and now it's, see the crashes as going up higher than the unique ones, because it keeps falling in there's big holes there, it keeps falling in the same hole. And it's good when it starts doing this to stop it. and work out what the problem is. And there I stopped it. Okay, so there's that. I'll just point out a couple more things about this. So it always seems to run at exactly half your CPU is what it works out. This machine's got 4 CPUs and it's using 200% because it's got 2 threads. I think the processors actually, and they're you know, they're completely parallel. And well, there's 2 sub-processors. So maybe we saw in that. Oh, there's me debugging it. Okay, this is looking through the Hong Fuzz report, saying where the problem is. I've got that in the real slide, so I can talk about that slower. Where was I? It's got a control process which is drawing this thing, and then it's got when it's crashing, it saves it, and then so persistent mode means that it's watching the it's running a program that is in a loop, calling your function, your fuzzing function, and then it crashes. It gets, if you've got the sanitizer on, it's always an abort, pretty much, unless it's the VT alarm. You never see a sig fault because it catches it first and aborts. And that kills that process and it starts a new one. So, and then this, you know, yeah, that's what you see there, a new one with that PID, and that was old one had that PID from there. I used an 80 by 24 terminal because so that or you sitting at the back could see it, which just kind of seems silly because you don't need to sit at the back, but that's what you do. And then it writes this section in for each crash, each unique crash it finds, it writes this section. So it's got, you know, the arguments, and says what it thought went wrong, heap buffer overflow, saves it to a file there. Now, annoyingly, that file usually contains things like this that you can't just copy and paste it into your terminal. You need to do it in single quotes and stuff. But that file kind of has essentially its entire description of what it thinks the problem is, of that identifies that crash. So then if it crashes again, another one crashes again, and it works out the file name. If it works out to be the same file name, it'll say it's not a unique crash. So it's, you know, that instruction, the stat was here, or that kind of stuff. So you'll find it's hard to know if they are the same crash. They probably are, but often you'll find essentially the same crash with a slightly different stack address, so you get a different copy of it, or sometimes thousands of them. So anyway, it's gone to A to I, which let's assume it's not that one's fault, and it's doing this time thing from the. This is the function we're fuzzing, and it's gone into that sub function, and then it's gone to here, hang on, I thought I had another slide there. Oh well, never mind, I didn't. So at this point, well, actually, I could probably just work this one out because it's not that complicated. But there are things that the address sanitizer and Hong Fuzz find that I just can't reproduce outside of them. And there are ways in which they interfere with GDB and valgrind and stuff. So you can't just run valgrind on this and expect, because address sanitizer and valgrind are both trying to do exactly the same thing in their own conflicting ways. Or maybe it's not address sanitizer, maybe it's the undefined behavior sanitizer, which I haven't actually turned on in this example because you can run with more sanitizers, which I'll get to later. So to get around this, we make an AFL build, which is like the Samba fuzzing word for no magic. The AFL stands for American Fuzzy Lot, which is another coverage-based fuzzer. And if you use the AFL compiler with the AFL build, you'll get coverage-based fuzzing. But if you don't use the AFL compiler, if you just use GCC, you get a nice test case with no magic. And so what I did is just clone the Samba directory, and then in this case, just from the local thing. And it said, I have two Samba directories, one with the fuzzer, well, I have real Samba directories, one with the fuzzer on, with the lib fuzzer on, and one with AFL on. So they're both building this, the fuzzing targets. One of them is building it with the lib fuzzer, the Hong Fuzz magic, and the other one is building it with no magic. And you did. Now before we didn't need to have enable debug because whatever the enable lib fuzzer also puts a -g there, but I found that the AFL one doesn't do that. So now what this does is this thing that we put in the in a little build thing. Normally, if you don't have this flag, that it evaluates to nothing, like nothing's added. If you do have the flag, this is a clever thing that Andrew did. It links in this a little main function that it's longer than this, but it does this basically. So it calls initialize, and then for all the arguments you give it, it runs the test on. So usually we're giving it one argument, and you're just saying, call the initialize, which usually does nothing, and then do this thing and see what happens. And that's why this kind of thing that's optional and libfuzzer isn't optional for us. So because it makes this harder. So then if I run it under valgrind, so if I run it with nothing, it won't crash because it's not stepping over, the boundary and all that stuff over the out of the page and do nothing. If you run it into valgrind, it kind of says the same thing. There was this function calling a to I, which valgrind looks one deeper. Now, because the Hong Fuzz magic compiler and address sanitizers and stuff, they use their own ATI or something like that. They have their own libc or bits of libc which are all a little bit different, and that's one of the reasons I like to do it both ways. So to debug this, you can look at the crashing function. So remember in our function, that first byte, we pulled that off and used it to make the flags, which obviously sent us down the LPRNG root, and then I don't know where it finds all these strings, but you know, it's got the whole of SMBD base to look at and think, well, these are interesting strings, and then so it starts off with stuff that it finds, and then you know, it thinks it might get somewhere with, and then it kind of randomly mutates it. So it's already quite a long way from the TV fuzz, and this has mutated it in such a way that it didn't take long actually, but it was a little bit more. I didn't want to show you screencast of me mucking around. You get to this thing. This is a bag. It's actually been it's from 1998 essentially. Before that we did these same things, but we had our own little local buffer, and people getting rid of F strings got rid of the local buffer, or rewriting stuff. Anyway, so now it's saying this. It's saying if there's a number that looks like it's less than 24, we go and look into the string, and that will be the hours, this will be the minutes, and that will be the seconds. But in this case, the string was $3 long, because I did this tokenization thing, found little bits, and it chucked it to this, and so it crashed because it was looking 6 bytes out instead of 3. Now I couldn't really work out whether that should be 7 or 8 because it's meant to be 2 digits, but it was like I didn't really care. And then the other case, when it's a bigger number, if it's more than 24, it's thinking it's a year, and it does it that way. And so we would hit the same bug there pretty quickly, so we can fix it then. So there's my t-shirt. I should get one now. I haven't actually opened the bug, and then running the fuzzer more. I have run it a bit more. It has crashed again. I haven't really looked into that. And I want to try and link this thing to a smaller subset of Samba, but maybe I don't really care. And then, so the thing, like if you make a new fuzzer, if you push it upstream before you've tried it, it might instantly crash when it gets sucked into Google's OSS fuzz. And then you've got a 90-day disclosure time, and you don't actually know if it's going to be easy or not. So I always run it over a weekend or several weekends. And my work desktop has like half its CPU is fuzzing for weeks on end sometimes. Okay, so then if you are when you are going to submit it upstream, if it's going to go into Google's OS, what is going to go into Google's OSS fuzz as soon as it touches upstream Samba, well, you know, that night, whatever. And OSS fuzz will complain if there are no seeds, and it writes emails to quite a few people about it. So if you submit the seeds to the Samba fuzz seeds directory, repository, at the same time as you put the fuzzer upstream, or a little bit before, then Google will be happy, right? OSS fuzz will be happy. Now, So minimizing the seeds is it. I'll just let's just put that. Go in there. So so that in here there's the run and the rotate and the results. And the results, this is why I tried to record it before so I wouldn't kind of do silly things. So in the results it's got that Hong fuzz. That's the you know, the log that I was talking about. It's also got the deadly strings for this one. That's the well, I want less on that one. So those are the things that crashed it, and those other ones are a log for each actual crash. The last number is the PID. Okay, and it doesn't really tell you anything more. No, it tells you a little bit more. If you looked at address sanitizer, you have seen things like that, but it will do it in color for you. And actually, it's not really going to tell us anything more because we have already fixed this one. Was this a new one? Yeah, that's the one. Anyway, I was going to show you. So that's got, because I linked it into the Samba seeds repository. It's got all of them, and what do we call it? Pars, that one. So it's found 1,897 seeds to throw at that that it uses as its breeding population to make new things to throw at the that fuzzer. And these are, you know, between them they cover everything, but they cover more than everything. And so if you run the minimizer, it'll go through, it'll find ones that don't add any coverage to it and throw them out. Whether it's throwing out useful leads or not is I'm not going to answer. It's possible, but when you're putting them into the upstream repository, minimizing them just means it's a smaller Git tree. So I do that. But yeah, so if you put a crash, if you're finding crashes, your seeds will essentially include those crashes, or there'll be something that, you know, it'll take half a second to find the crash from the seeds. So, and if it's a bad crash, a security crash, you don't publish your seeds until you fix the crash. So this is why you've got to be careful about what you publish with your seeds. So I mean, in this case, this printer thing is getting it from another process running as root, I think, and it's a kind of printer that nobody uses probably, and it's just, you know, it's not an issue at all. But just be careful. Okay, now I've talked a little bit about this. OSS Fuzz runs doesn't run Hong Fuzz. It runs another thing that uses libfuzzer, so it uses the same API of, you know, this funny VM functions. It put everything that's in the upstream tree, it pulls in, and it gives you 90 days to fix it. Now we've got things that we've got 90-day disclosure windows that have just come and gone because there are things there are we've got fuzzers that find things that no other code uses apart from the fuzzer. I mean, you could argue that we shouldn't have those fuzzers, but we do that. And also there are things. Okay, I've got slides about this stuff, so I'll wait until I get there. Yeah, and it gives you a bug page like this. Now I'm not signed in on this browser, so I can't go and see you get quite a lot of information there. These people get it, email about them all, and this one, the 90 days came and went, I think. Yeah. And that one is a timeout, and it's probably Cole talked about this. Now I'm confused about this. This is a meta section. I'm confused about the time. I can't remember. At what time did I start talking? It's 2:30 in the morning for me, so I'm a bit confused. And how long do I have? Did I start at 1:15? Oh, do I need to find a chat window? How do I even do that? Oh, I can't find a chat window. I'm guessing I started at 1:15 and I go to 2:45 and then I've got 20 minutes. Is that right? Anyway, if someone could say that would help me. So if you push a fuzzer that you know will find the crash, it's a bit like disclosing the crash, because apart from OS's fuzz, anyone else can come and get it. But of course, anyone else can fuzz Samba anyway. So especially after this, and it sets you up for the 90-day things. But so I try and run my fuzzers for a while, make sure that it's kind of safe, and then once it's safe, that seems boring to push them. So they're never kind of a priority. So I've actually got quite a few lying around, which I'm going to get into. The activity that it ends up causing is less in writing fuzzers and more in kind of debugging funny little things that it finds, which is, I quite like it. It gives you nice little, that's bad spelling. It gives you nice little puzzles, or sometimes they're too little, sometimes they're too big, but often there's like, you got to think about bits and bytes and stuff. Here's a good trick. This is Andrew's thinking and work. We have one file, fuzzndix.c, that fuzzes 159. Well, it makes 159 fuzzes, and each of them that does the NDR pull, and then it does a print or something like that, and then it does a push. And the print kind of stands in for all of the processing that you might want to do with an NDR pull, into an NDR struct. And it's found quite a few issues. There are quite a few NDR pipes that nobody uses, and some of them have had crashes or timeouts, and we've pretty much just ignored them. That's a lot of the OS's fuzz ignored things, is that Nobody's using their witness pipe, I think, and things in the witness are not all good. And there are also, I'll talk about the problem. The problem I was going to mention is timeouts, but I've got a slide about that later, so we'll wait till that. Now, this is another kind of trick you can do. If you get your blob, if you can just pull off bits of it and use it to deconstruct it. So, like, this is for things that take 3 strings. You can just kind of pull off a length and another length and another length from the first 6 bytes, and then work out. And then basically you split your data blob into well, in this case 3 strings, but you can split it into 3 blobs, or 20 blobs, or like we saw before, into flags and all kinds of things. You can use the data however you want. For the input size, you edit that fuzz run, and as I think I said before, if you start small, you kind of, by small I mean like 5,000 or something more, 1,000. It runs fast. You get an overview of how it's going, and it's not. If it's going to megabytes and it's doing evolution on the millionth byte, and your thing that you're fuzzing with is stopping at the first null byte because it actually wants a char string. Then it wastes a lot of time doing useless stuff. But if you keep it short, it can't waste so much time. And then increasing, then it gets a whole lot of short seeds, and then you can increase the window, and it will start making longer things if there's any use in it. So it's kind of like, start with the most likely easy thing, and then grow. Now for some things like TDB, there's if you give it certain things that are exactly 4096. If it's got 4096 bytes in the file on disk, TDB will segfault if those bytes are in a certain bad situation. So if you didn't have 4096 byte strings in your, if your max size was smaller than that, you wouldn't find those. So that's, and there are other things possibly that have got much larger dependencies, but generally in Samba we're actually dealing with little things anyway. It's good to go a little bit over, what would seem like a natural limit. Like, you don't stop at 1,024, stop at 1,028, or 5,000 instead of 4,096, or not 65,536. Go to 70. Right, and so I didn't add this flag onto the original compile string, but it's worth it. The undefined sanitizer. It doesn't crash. I always use fuzz. Somehow it runs the undefined behavior sanitizer as a fuzzer. But we, in our one, it just writes a little log file, and the log files are it's pretty cryptic, and that it always has this line that just goes in, it's about to say something and stops. But the first line tells you, something bad is going on. And in fact, this is from a crash in that fuzzer we were talking about that happened after the other one, which I didn't have time to add. So, and you don't know which input file caused this little thing to happen, but you know the line. Undefined behavior, usually you get told the line, you look there and you can work it out. And often it's something stupid, like a stupid foot to complain. It's something you need to add a U on the end of your shift thing, and it's undefined, and I mean there are some undefined things that the compiler could choose to do something stupid on, and it never will. But it's okay because you can just fix it. And so this is I'm talking about problems that you sometimes find. The address sanitizer kind of just comes sometimes. You can't really tell what it's on about, and valgrind doesn't know what it's on about, and you can look, stare and stare and stare and stare, and can't see anything wrong, and you don't know what it wants you to fix, and nothing else wants you to fix it, and so sometimes that just happens to me anyway, that I just can't see what's wrong, and sometimes even things like address sanitizer have bugs, and they have their little libraries of these little functions that are all instrumented, but they can still be buggy, or just, even if they're not buggy, they're just not the same as GNU libc, and so I never see why it doesn't work like that. We often get false positives from things where we're growing a list or an array, or and we don't expect that we're going to add 10,000 things, so we add them one at a time with a really conservative little reallop. And address sanitizers reallop is super careful, and libc's one is not, and or like it probably does things like it has allocs a few extra bytes, so that next time around you just get the same thing back or something. It knows how to do it faster, and 100 times faster or more. So we've had lots of timeouts, and OS's fast way of saying, this is dreadful, this will lock up your program, and then when you run it without the magic, it just goes just like that. There's nothing there. So some of those I have fixed by allocating more at a time, but it's not really a fix. It's just following orders. These are things that I can't quite manage to do. I haven't really managed to make something that works with T-event work in a fuzzer, because I don't have any examples to work from, and I don't know really how to make the event loop work in a fuzzer. And it's partly I'm allergic to writing lots and lots of code, and I like these little things, and I feel like there should be a way. I just don't know what it is. And this is kind of related. A lot of our functions just kind of have huge amounts of all kinds of auth contexts and stuff like that. And the LP config and all that, everything. And I'm just it's a lot of work to get all that stuff lined up just to fuzz some little thing, which you don't actually, usually you don't care about it, because the function you're actually calling doesn't care about all that stuff, but the function is always used where that's around, and just, it might just want one little bit of the auth context, but you don't pass that into the function, you pass the whole thing. Yeah, unit tests and fuzz targets are pretty much the same thing, except the unit test, you write a string and you assert that it's going to do something. If we had more unit tests, which would involve like mocking up the auth context and stuff like that, then we would be able to have fuzzes that you just change a couple of lines and you pretty much have a fuzzer. So if something's unit testable, it is fuzzable. It's sort of the same thing. So yeah, like this one that we wrote the fuzzer for, it's actually only called in this function here. Funnily enough, this one is a public function. This one's static, but anyway, I think they're in different files. But this function, you can't really fuzz that one, because it does run print command, and then it gets a file thing, and then it loads the lines and all that kind of stuff. Yeah, I mean, I guess you could somehow overload. Well, I don't know what you could do. So, but this one is, it takes a data blob and you just bang it in. And but if you could do the whole lot, then, like, for instance, I think we're splitting on somehow it's splitting on lines. So I mean, it's expecting a line. It's never expecting to be a carriage return inside that blob it's getting, but we're passing it that, and which is a little bit unfair, but it actually doesn't care. It doesn't. Nobody wants to pay for it, and so it's actually a bit of a commercial disaster to get into fuzzing. It might be better for David, and like, we benefit from open source. Like, the fact that we can see the source means we can do coverage-based testing, not, just kind of black box testing, or you can do a little bit better than that. You can do kind of with I guess timing attacks on closed things, but anyone can fuzz Samba, and I've found it's not too hard to find bugs. I don't know if many of them are super exploitable and taking over your domain kind of ways, but they can certainly be a nuisance. And now the question mark means I've run out of slides. Does anyone have any questions? And how do I get to see the chat? If I can, if I could work that out, I would. What's that doing?
At the bottom of your screen, you should have a chat bubble.
Chat bubble? I don't have a chat bubble.
Just move your mouse around.
Oh, okay. So I've got that where? No.
Maybe when you go with your mouse on the top of your screen.
I get a little X there, and I get.
I think it moves it when you're screen sharing.
Right. I'll stop screen sharing. That would. I don't know if I am stopping screen sharing. Don't. Sorry for being a bit useless at this business.
Yeah, I think there are some issues as well, because we see like black boxes in your screen, which it seems like that doesn't seem right.
I think Andreas had those too. No, I didn't intend to have black boxes. Anyway. So does anyone have any questions? You have to speak.
So I picked up your talk from the part 2, which makes it hard to follow. But I mean, without explaining the whole thing again, I guess I'm interested in fuzzing the new SMB server in the kernel.
Right.
And I was wondering if I could reuse some of the things you mentioned, because since it's in the kernel and you have to use QEMU to boot a new VM to test it, I'm sure it would work differently.
Yeah. So, the things, the way I was explaining of doing it is kind of making new binaries that just fuzz a tiny part of it, or an interface kind of thing. I don't know if you could do that with the kernel of just taking a function basically, and the things that it depends on, and turning that into a binary, or just a kernel, just a mini kernel that does one thing.
Yeah, that would be a lot of work, I think.
Yeah. I assume so. I can't really help you.
I know, so you can build the kernel with this k-asan thing. So there is a way to make asan interact with. So if there's something detected, it gets printed in the DMSG, this system log basically. So I mean, you can trigger asan warnings. So that's, I mean, this part is handled, I guess, but
there are kernel fuzzers that people do run. I haven't looked into them, of course, because I'm not dealing with that. There was, I mean, I think they kind of tend to focus more on syscalls. Is that?
Yeah, sorry, I don't have any questions specifically for your things, because as I mentioned, I caught it in the middle. Yeah.